Good afternoon. Firstly, thank you, Dan, for your kind introduction. And I would like to thank SoilsWest for inviting me to give this presentation. And special thanks to Tina and Fran for helping me with this seminar presentation. And also, I would like to thank every one of you who have joined to listen to my presentation. So this is the title of my presentation. The ground's generosity takes in our compost and grow beauty. Compost promotes soil health and productivity. Now, before I embark into my seminar presentation on this topic, I'd just like to talk about my research activities briefly. This is my research topics: soil health and farm productivity, carbon sequestration and climate change, contaminants in cannabis and complementary medicine, soil remediation and including phytoremediation, waste management, and microplastic. Now, soil health and productivity, the main focus of our work is on the beneficial value of bio-waste that include compost on soil health and crop productivity. So what I'm going to talk to you today is based on this particular research area. Carbon sequestration and climate change mitigation. Here the main focus is increasing soil carbon sequestration through improving biomass productivity by increasing nutrient use efficiency or residue return, including clay input in sandy soil. I think the main approach to improve carbon sequestration is to promote photosynthesis, that is by increasing biomass production. That helps the soil health, then thereby you increase the carbon sequestration through increasing photosynthesis. Contaminants in cannabis complementary medicine. The main focus here to quantify bioavailability of heavy metal contaminants in cannabinoid and complementary medicine. Now you must be wondering what I got to do with cannabis other than smoking when I was a school kid. The University of Newcastle as a center funded by NHMRC on medicinal cannabis. I'm one of the CI in that center. Our focus is main on contaminants because contamination is a major issue in recreational cannabis. A good example is adulteration with lead to make some profit. Both cannabis and lead are psychotic. So it's a double trouble. So we are looking at the bioavailability of these contaminants in cannabis and also complementary medicine that include Ayurvedic medicine, Chinese herbal medicine. Now, soil contamination and remediation. Here again, main focus is to manipulate bioavailability of contaminants to manage risk-based remediation. Risk-based remediation is very critical because it will be impossible to remove every contaminant. If we can reduce the contaminants reaching the food chain by manipulating bioavailability, we can reduce the risk. Now, waste management. Sustainable waste management is a very serious issue. Comes under circular economy. Recently, we have been focusing on microplastic, which include nanoplastics, contaminants in soil. A lot of work has been done in aquatic system. So we look into soil. So this is the brief introduction to my research areas. Now, I will get into the main topic. The ground generosity takes in our compost and grow beauty. Try to be more like the ground. This is one of the famous quotations by Persian philosopher Rumi. The title is Ground Generosity Takes in Our Compost and Grow Beauty. So Rumi gives the credit to the ground, but I believe it is the generosity of the compost which makes the barren ground healthy to grow food and for human and animal consumption. So that's why I came up with this title. So this is going to be my outline. Briefly, I introduce sources of organic amendments, then multifunctional values of organic amendments. Then I will talk about the organic amendments in relation to soil health, physical health, chemical health, and biological activity and function. Then some conclusions. The sources of organic amendments. There are a number of sources of organic amendment that include manure compost, green waste compost, farmyard manure, biosolid, biochar, vermicompost, very many. Around 7 million tons per annum of organic amendments or materials are produced in Australia. So there is a very good value in utilizing this organic waste. So what are the multifunctional values of organic amendments? Organic amendments provide nutrients and carbon. These are the two important components of organic amendments. But it has multifunctional applications. It improves the physical fertility, chemical fertility, biological fertility, carbon sequestration. It can be used for soil remediation in the areas of organic contaminants. Increasingly, organic amendments can be used as a nutrient and microbial carrier. So there are multifunctional values of organic amendments. So, but I'm going to cover physical fertility, chemical fertility, and biological fertility. Now, organic amendments modulate soil health. So what we have done is we undertook a meta-analysis to look at the effect of organic amendments in improving some of the soil fertility aspect. That's what I'm going to cover. Before I get into meta-analysis, I would like to briefly introduce about the meta-analysis. Meta-analysis can be used to identify and compare common treatment effects amongst multiple studies. In this case, we are looking at the effect of organic amendments on various soil properties, physical, chemical, and biological. Meta-analysis provides quantitative information on the effect of organic amendments on the change in soil properties. So here, the bottom axis is the change in soil property. That's the difference between treatment and control. Here, the treatment is organic amendments, and the control is without organic amendments. On the right side of the bottom axis is the percentage increase, that's the plus. On the left side is the decrease due to organic amendments. So you can see, for example, microbial biodiversity invariably increases with organic amendment input. So this is the range in the values derived from various studies. So those dot points are the number of studies, just given an example. For example, hydraulic conductivity, sometime it can increase, sometime it can decrease, depending upon the soil type. Soil compaction invariably decreases with organic amendments. So that's what I'm going to give some examples for physical, chemical, biological fertility aspect. So we have examined around 360 studies. We grouped the organic amendments to manure compost, green waste compost, farmyard manure, vermicompost, biosolid, and biochar. So when I give the data, I will be giving the data for these various groups. We can group them in a different way, but this is what we did. The message here is the effect of organic amendments on various soil properties varied with the type of the organic amendment, the level of input, soil type, and environmental conditions. I'm not going to give some of these factors. What I'm going to give is the effect of various organic amendments on some of the physical, chemical, and biological properties. Let us start with physical properties and processes. I believe organic amendments is very critical to improve physical properties. You can fix the nutrient deficiency by adding fertilizer. For example, you add urea, it's going to supply nitrogen. But it may not do much to the physical health of the soil. So, now this figure gives the effect of organic amendments, the various types I've indicated, on some of the physical effect. Here, penetration resistant, which is compaction, aggregate stability, which is structure, bulk density. So you can see that the compaction, which is the green one, invariably decreases with organic amendment. So that means compaction decreases. Aggregate stability, which is the red one, increases with organic amendments. That means you build more soil structure. Bulk density invariably decreases because organic amendments are lighter and decreases the bulk density of the soil. There are times it can increase depending upon the soil type. So the message is compost application improves soil physical properties such as bulk density, aggregate stability, and compaction. Just continuing on the physical properties, water fill pores, hydraulic conductivity. Again, most of the compost or most of the organic amendments increases the water filled pore space. That means you can retain more moisture. Hydraulic conductivity mostly increases because you make the soil more porous. But there are times, for example, in the case of biochar, it can decrease the hydraulic conductivity, which again depends on the soil type. Biochar can form very tiny particles which can block the pores, so therefore it can decrease hydraulic conductivity. Now what we did is we look at some of these organic amendments and look at the water holding capacity for a sandy soil and clay soil. The red one is clay soil, and the green one sandy soil. The first two bars are the control without organic amendments. So you can see organic amendment application increases the water holding capacity. And the effect was more in the case of sandy soil than clay soil. Western Australia has more than 58% sandy soil, very high, and also South Australia. So organic amendments can improve the water holding capacity, thereby providing drought resilience, which is very important. Now let us look at the chemical fertility. Now, chemical fertility, the important aspect is nutrients, because most of the organic amendments, they are plant or animal derived. Therefore, they will have most of the nutrients. So this gives, the bar diagram gives the nutrient content of some of these organic amendments: nitrogen, phosphorus, potassium, sulfur. Just to give you an example. So most of them can contain these nutrients. The nutrients can reach up to 3 to 4% nitrogen, depending upon the organic amendments. Around 2% phosphorus. For example, poultry manure can contain a lot of phosphorus. Organic amendments can contain potassium also. So what I've given in this meta-analysis is the change in nutrient content: nitrogen, phosphorus, potassium, and sulfur, with the addition of all these organic amendments. So you can see it's all positive because all these organic amendments contain these nutrients. By adding the organic amendments, you will be increasing the nutrient content. So this one gives some of the other chemical properties with the addition of organic amendments: pH, electrical conductivity, cationic chain capacity. Now, in the case of pH, depending upon the soil type, it can increase or decrease, because organic amendments is a good buffer. When the soil is acidic, organic amendments can buffer and increase the pH. So it depends upon the soil type and the organic amendments. For example, biochar, the bottom one. Most of the biochars are alkaline in nature. So you can use it as a liming material. So by adding biochar, invariably increase the pH. Now electrical conductivity, invariably electrical conductivity increases. This could be one of the problems because organic amendments are generally high in electrical conductivity because salt content. So it can cause problem with salinity. Cationic chain capacity, most of the organic amendments are having higher cationic chain capacity compared to soil. For example, biochar, the cationic chain capacity can go up to 30 centimoles per kg, whereas in the soil, not more than 10 centimoles per kg. So therefore, organic amendments application increases the CEC, which is good, but it can also increase electrical conductivity, which may not be good. Most importantly, organic amendments act as a pH buffer. Now I'll just give you a couple of examples for nutrients. Now this gives the nutrient leaching for biochar, control, urea, urea plus nitrification inhibitor, urea plus biochar. So you can see that biochar addition reduces nitrate leaching from soil. It is not better than nitrification inhibitor, but still it decreases nitrate leaching. That's because organic amendments, or biochar in this case, can absorb nitrate and also cause immobilization of nitrate. So therefore, you decrease nitrate leaching. Here, nitrous oxide emission, again biochar. You can see biochar decreases nitrous oxide emission, not as good as nitrification inhibitor, but nevertheless it decreases. Because biochar itself can act as a nitrification inhibitor. Biochar can contain PAH, which can cause nitrification inhibitor. That's one of the issues with biochar, because it can contain PAH, which may not be good. So the decrease in nitrous oxide emission can be related to decrease in nitrate source and a change in soil water content. So what I'm trying to say is biochar can increase the nutrient use efficiency and also provide the nutrients. Now, finally, I will look into biological activities. Now, this is a very critical component. My neighbor, Dr. Pete McCon, he believes Organic amendments improves biological fertility, which is a very critical component for soil health. I totally agree with that. You can add urea, it may not improve the biological health, but organic amendments, which are very rich in biological activities, can increase the nutrient, the biological activities. So this gives the effect of organic amendments on some of the biological properties. Basal respiration, dehydrogenase activity, and microbial biomass carbon, microbial activity. So you can see that invariably most of the organic amendments increased the biological activities as measured by some of these biological properties. There is not much work done on the effect of organic amendments, various biological properties. That is one area which will be very interesting to look into. So what we have done is here, we took an uncontaminated soil and a copper contaminated soil, and we measured dehydrogenase activity by adding various types of organic amendments. The first part is the control without organic amendments input. And the red one is copper contaminated, and the green one is uncontaminated. So the DHA activity, enzyme activity, was less in copper contaminated soil because copper is highly toxic to microbes. Organic amendments increase the enzyme activities, but the most important one is the effect was more in the case of contaminated soil. So organic amendments increase the microbial activity of the contaminated soil by reducing the metal toxicity. So that's why organic amendments can be added to remediate contaminated soil. So the message here is organic amendments directly increases the microbial activity because they have high microbial activity, diverse microbial activity, but organic amendments can decrease the bioavailability of the contaminants, thereby reducing the toxicity of these contaminants to the microbial function, thereby increases the microbial activity. So organic amendments induce increase in soil biological activities can be attributed to co-location of various resources in organic amendments, nutrients, carbon, which are very important for the microbes. And also, organic amendments inactivate the growth inhibiting substances. I just show you an example of copper contamination. The organic amendments can complex or absorb copper, thereby reducing the toxicity of the contaminants to microbes, thereby increases the microbial activity. So we covered the effect of organic amendment on physical health, chemical health, and biological activity and function. As indicated right in the beginning, we can overcome nutrient deficiency by adding inorganic fertilizers. But organic amendments are very critical to improve the physical health and biological health, in addition to providing some nutrients. So some are the conclusions. Organic amendment application improves soil physical properties such as bulk density, porosity, moisture retention, more importantly, soil structure, because that's a critical issue in the case of sandy soils, because soil structure is very critical for the root growth, moisture retention, nutrient availability. It reduces erosion. Soil structure is very critical for drought resilience. Only organic amendments can provide that benefit. Organic amendments contain most of the plant nutrients, and the concentration of the nutrient depends on the nature of the feedstock. Organic amendments can provide some nutrients, but it cannot substitute the nutrients supplied by chemical fertilizer. So that is one of the issues why organic amendments is not reaching the mainstream agriculture, broad acre agriculture, because to provide all the nutrients, we need to add so much of organic amendments. So one way to overcome that is what we call blended fertilizer. We may need to add chemical fertilizer to organic amendments, what we call carbon-based fertilizer, so that you can supply the nutrients and at the same time you provide carbon, which can improve the physical fertility. So that's blended carbon-based fertilizer formulations. Organic amendments increases soil cationic capacity and also soil nutrient concentration. In sandy soils, one of the problem is nutrient leaching, because there is not enough cationic change sites. By adding organic amendments, in many cases clay, we can increase the cationic change capacity and thereby increase the nutrient retention, reduce the leaching, increase the nutrient use efficiency, especially in sandy soils. Organic application decreases nutrient losses through leaching and gaseous emission. The most important one is organic amendments improve soil biological health, thereby increases soil productivity. So when you increase the biological health, you can increase the nutrient use efficiency. So thereby, you can reduce the amount of fertilizer input, because you are going to increase the nutrient use efficiency. So without organic amendments, you may need to add more fertilizer. But when you add organic amendments, you can reduce that input. So what is the take-home message? Organic amendment application improves soil health, mainly the physical health and biological health, thereby increasing crop production and reducing the environmental impact of nutrient losses. Currently, organic amendments is mostly used in horticultural and landscape system. So there is an interest by the industry, by the end user, like farmers, by the researchers, like you and me, to increase the use of organic amendments in broadacre farming. The problem is you need large quantities of organic amendments. So more field studies, and more importantly, cost-benefit analysis are required under broadacre farming conditions, mainstream agriculture. But the real challenge is the consistency and the quality and the cost of organic amendment product. It is very difficult to maintain the consistency and the quality of organic amendments. But a lot of work has been going on that, because you need to provide some parameters or quality indicators. What is the carbon content? What is the nature of the carbon? What is the nutrient content? So these are some of the challenges in the industry. Finally, I would like to thank my past and present students who have helped me to present this seminar. Again, finally, I have to do some advertisement for some of our books on biochar and particulate plastics. Once again, Dan, thank you for your kind introduction. Tina and Fran for organizing this seminar. For every one of you who have been listening to this,